Hello student, today we are going to start the applications of the multiple integral. In that, the first application of the multiple integral is nothing but a area. So there are different formulas to find the area bounded by the curve. So here area by single integrals. So let y equal to f of x be the given curve. Area enclosed by the curve y equal to f of x axis, and the lines bounded by x equal to a, x equal to b is as shown in figure. So what is that formula? That formula is integration from a to b f of x dx, that is equal to integration from a to b y dx. If suppose that area bounded by y equal to c and y equal to d like this, it means that let y equal to f of x be the given curve and area enclosed by the curve x equal to f of y axis, and the lines y equal to c to y equal to d. Then the area equal to integration c to d f of y dy equal to integration c to d x dy, means any one from this. In polar coordinates, it means that r and theta. Let r equal to f of theta be the polar curve. Then the area a equal to integration from alpha to beta. So these are the limits of theta. So theta 1 to theta 2. So integration of alpha to beta r square d theta as shown in figure. So area by double integral, it is our interest. If the area bounded by two curves y equal to f1x and y equal to f2x and x equal to a to x equal to b, then area a equal to integration from a to b, inner integration from y equal to f1x to f2x dy dx. And if the area bounded by two curves x equal to f1y and x equal to f2y and y equal to c and y equal to d as shown in figure, then the area a equal to integration from y limits from c to d, inner integral from x limits f1y to f2y dx dy. So what you have to remember? So in short, you remember area a equal to double integration dx dy and bounded by whatever the curve. So find the limits of that and you substitute here and evaluate this. This is your formula. So finally you remember only this, area equal to double integration dx dy. And suppose I want to convert into polar, then you remember x equal to r cos theta, y equal to r sin theta, and dx dy equal to r dr d theta. So this formula becomes now r dr d theta, double integration r dr d theta. So by using this, you can solve each and every example of this area. Let's consider one example. So example, find the area bounded by the parabola y equal to x square and the line y equal to x. Before to start this, you should know how to decide the limits. So you must go through all videos of double integration. So here, very clear that formula, we know area equal to double integration dx dy because given curves are in Cartesian form. So here, you find the area bounded by. So here I will write A. So area is what? Bounded by y equal to x square and line y equal to x. So draw this figure. Roughly you draw the figure and find the limits of x and y. So here is the curve or area bounded by y equal to x square and y equal to x. So here x axis, here y axis, here y equal to x square, it is a parabola symmetric about y axis, and y equal to x. Y equal to x means this is a line and this is a parabola. So bounded by this, it means that a region of the integration is this much. So how many boundaries of this curve? There are two boundaries. So boundary points here, it is a 0, 0. And if we put this value here, so I will get y equal to y square, and this implies that y square minus y equal to 0. Y common, y minus 1 equal to 0, y equal to 0 and y equal to 1. Means definitely this point is 1, 1. So roughly we have to find. Note that it is not a curve tracing. So roughly we want limits. And now take a vertical strip. You can take horizontal or vertical, any strip. So definitely here limits are. It is a vertical strip, it cut to x-axis means x constant and y varies from curve to curve. And here x constant. On the x-axis we will find the boundary points. So curve to curve. So what is this curve? This curve is y equal to x square. 2. This line, what is it? It is a y equal to x. And x equal to boundary points on x-axis, x equal to 0, 2. If we draw this one, so I will get here x equal to 1. So 0 to 1. And that is why I am getting the area equal to, for required area a equal to integration 0 to 1, inner integration x square to x dx dy. Note that inner integral contains x. It means that integrate with respect to y first. So only y inside. So integration from x square to x. Only y inside and outside dx. What is the integration of dy? So integration 0 to 1. I am getting only y. Lower limit x square. Upper limit x dx. So upper limit minus lower limit. So I am getting area equal to integration 0 to 1. Upper limit minus lower limit into dx. Now integrate with respect to x. So I am getting it is a x square by 2 minus x cube by 3. Lower limit 0, upper limit 1. So area equal to upper limit is 1. So 1 by 2 minus 1 by 3 minus 0 because lower limit x equal to 0. So I am getting answer or area or required area 1 by 6. So required area is what? It is a 1 by 6 which is your required answer. So example, find the area between the curve y square x equal to 4a square into 2a minus x and its asymptote. So note that here when we are going to start the applications of the multiple integral, we should know roughly how to trace the curve, how to decide the limits of double integration and triple integration, and also the curve tracing and beta and gamma functions. So here what we want to find area, it is a Cartesian curve. So we know the formula. What is the area? Double integration dx dy over area A, and this area A is bounded by the curve y square x equal to 4a square into 2a minus x and its asymptote. So note that here it is not a curve tracing part. So roughly even though I am getting what type of curve is there, then also it is sufficient. So definitely when we put, so actually this curve is what? It is a y square equal to 4a square into 2a minus x, and we want 2 points. One is asymptote and second that curve where it cut to either x or y axis. So when we put here x equal to 0, what we get? We'll get y equal to infinity. And when we put y equal to 0, what we get? We'll get x equal to 2a. So it is very clear that that curve passed through x equal to 2a. Also next thing is what? Here x equal to 0 is asymptote. How? Because our interest is asymptote and highest power in x and y you find. Highest power in x is what? So I am getting here xy square equal to 8a cube minus 4a square x. If we common out here, the highest power is x, so I am getting here y square plus 4a square into x equal to 8a cube, and coefficient of x, highest power in x, is nothing but this one. And if we put this is equal to 0, which is not possible. Why? Because y square is negative. I am getting negative, which is not possible. Then what is the highest power in y? So highest power in y is a y square, and what is the coefficient of y square? It is x equal to 0 is asymptote, and also this gives the asymptote because here y is infinity. So that curve is definitely x equal to 0 means y axis is asymptote and it passed through x equal to 2a. So here supposed to be x equal to 2a and this one. So nature of the curve is like this, or maybe this one. So curve or nature is not important. Our interest is that it bounded between this x equal to 0 and here x equal to 2a line, and here it is asymptote and here the curve may be like this or maybe like this. So anyhow we can decide the same limits there. But what is the actual curve here? So this is your actual curve, it bounded. So here you can take the area bounded between this asymptote, means this is the asymptote and this is a curve in between this. So this area I want to find. So since it is a symmetric about x-axis, so whatever area of this one, it is same as here. So that is why I can consider the required area is 2 times. So but what about the limits? You can take here horizontal strip or vertical strip, any strip. So here I am taking vertical strip. So what are the limits? So vertical strip, that is why it cut to x-axis, x constant and y varies from curve to curve and x constant. So y varies from. So what is the value of y here? I am taking here the same area here and here. So a1 plus a2 equal to a total area. So first part here only above part of x-axis. So y equal to 0 to y equal to curve. What is that curve? That curve is this one. And what is the value of y, it is under root of 4a square into 2a minus x upon x. And here what about the x values? X starting point is 0 to where it ends. It is a 2a, 0 to 2a. So required area is a equal to 2 times integration from 0 to a, because these are the limits of x. And what about the limits of y? 0 to under root of 4a square into 2a minus x upon x into dx dy. Note that inner integral contains x, means these are the limits of y. So only y inside. So I am getting area equal to 2 times integration 0 to a, inner integration 0 to under root of 4a square into 2a minus x upon x, and only dy inside. You can take direct steps also by practice, but here I am solving stepwise. So directly you can decide that is a y, because here also it contains x, means integration with respect to y, only dy is there. What is the integration of it? It is nothing but y, lower limit, upper limit. But stepwise I am solving. So area equal to 2 times integration 0 to 2a, it is a y, and lower limit, upper limit you substitute 0, and under root of 4a square into 2a minus x upon x, and dx as it is. So upper limit minus lower limit. Now here you simplify. So I am getting area a equal to 2 times integration 0 to 2a. Upper limit is what? Under root of 4a square into 2a minus x upon x, whole thing in under root, and dx. So I will simplify here now. It is a 2 integration 0 to 2a. So under root of 4a square, it is a 2a. Under root means it is a power half. So I am getting half 2a minus x raised to half, and here x raised to half dx. So 2a constant, so you take outside. So I am getting here area equal to 2 into 2a, and same thing I can write 0 to 2a, x raised to minus half, and 2a minus x raised to half. And here I will use a beta function. So what is a beta? We know beta of mn equal to integration 0 to 1 x raised to m minus 1 into 1 minus x raised to n minus 1 dx. So here I want 1 minus x, and that is why I will substitute here x equal to 2at. So what is the dx? It is equal to 2a dt. And what about the limits from x to t? Given limits 0 to 2a. If we put x equal to 0, so I am getting t equal to 0, and x equal to 2a. 2a by 2a I am getting 1. And that is why area a equal to, outside it is a 4a now, integration 0 to 1 x raised to minus half. So it is a 2at raised to minus half into 2a minus x, means 2at raised to half, and dx is 2a dt. So note that here outside 4a and now 2a constant here, here and here. So what is the power of 2a? So here I am getting power of 2a is a minus half. Here I am getting 2a common. So plus half, and here it is a 1. So finally I am getting power 1, means only 2a. And inside integration 0 to 1, here t raised to minus half into 1 minus t raised to half dt. So by using this beta function, I can write here it is a power plus 1 and power plus 1. Note that I already said that you must know how to trace the curve, means curve tracing, how to decide the limits, means double integration, and third thing is that beta and gamma functions. So area equal to 8a square, and here beta power plus 1 means minus half plus 1 half, and half plus 1 means 3 by 2. As we know, beta mn equal to gamma separation means gamma m gamma n upon gamma addition means m plus n. And by using this I am getting area a equal to 8a square gamma half into gamma 3 by 2 upon gamma addition half plus 3 by 2. So half plus 3 by 2, it is a 2. So I am getting it is a gamma 2. And by standard values, gamma half is root pi, gamma 3 by 2 is 1 by 2 root pi, and gamma 2 is 1 factorial means 1. So finally I am getting required area equal to 4a square pi, which is your required answer. So example, find the total area bounded or included between two car divides r equal to a in bracket 1 plus cos theta and r equal to a in bracket 1 minus cos theta. So definitely these are the polar curve. So we know the formula for area in polar form is r dr d theta. So now decide the limits of r and theta. But before to that, the area bounded between these car divides you find. So very simple. It is a car divide. First car divide is this one. So definitely when theta equal to 0, so cos 0 is 1, so 2a. So here I am getting 2a, r equal to 2a, and when theta equal to pi by 2, cos pi by 2 is 0, so I am getting here a. And here it is a when theta equal to 0, I am getting 1 minus 1 0, and when theta equal to pi by 2, so I am getting here 1 minus 0, it is a. And when theta equal to pi, so cos pi is minus 1, 1 minus of minus 1, it is a 2a. So in negative direction I am getting a car divide. So roughly I am getting this is a car divide bounded between these two. Note that, which we want to find. So definitely this area, it is a 4 times of this, same as here, same as here and here. So it is only we want to find this part, this red color part we want to find. So actual area we want to find this, and we can consider required area equal to 4 times of this one. Now problem is that how to decide the limits. So note that here what is theta equal to 0 and here theta equal to pi by 2. So limits of theta very clear, theta 0 to pi by 2. But what about r? So this curve, note that here this car divide I am taking. So here from 0 to this car divide means it is a negative, r equal to a in bracket 1 minus cos theta. This car divide. So what are the limits of r? 0 to r equal to a in bracket 1 minus cos theta, and theta equal to 0 to theta equal to pi by 2. So very simply we can find this area, and required area is a 4 times of this. Now in detail you find the curve. But in exam this curve is sufficient, only you decide the limits and you just put here and evaluate which is your required answer. But now here for practice I will draw carefully this curve. So here curves r equal to a in bracket 1 minus cos theta, this car divide, and this one is r equal to a in bracket 1 plus cos theta, bounded by this. So actually this is the area which we require, but I will consider only one part of it, which is nothing but this part, and here you decide the limits. Here this is the radial strip, definitely here theta equal to 0, here theta equal to pi by 2, and what about r? Here r equal to 0 to this blue curve means r equal to a in bracket 1 minus cos theta. What are the limits here? I can write here limits. So r equal to 0 to, always you find the limits of r equal to 0 to a in bracket 1 minus cos theta, and theta equal to 0 to theta equal to pi by 2, and required area equal to, that is a equal to 4 times integration 0 to pi by 2 and inner integrations of r 0 to a in bracket 1 minus cos theta r dr d theta. So now inner integral contains theta means these are the limits of r. So only r inside. So easily we can evaluate this. So 0 to pi by 2. Here inner integral 0 to a in bracket 1 minus cos theta, and only r inside. One may write it directly r square by 2, put the lower limit, upper limit. But okay, here I will find stepwise. So 4 times integration 0 to pi by 2. And here I am getting r square by 2. Lower limit is 0. Upper limit is a in bracket 1 minus cos theta and d theta this as it is. So r square by 2. So 2 outside. It is a constant. So 4 by 2. Definitely I can consider it is a directly 2. So upper limit r square. So a square in bracket 1 minus cos theta whole square minus a lower limit, it is a 0. So that is why I am getting this thing. So a square is a constant, you take outside. So I am getting a 2a square integration 0 to pi by 2, and here 1 minus 2 cos theta plus cos square theta. d theta. So integrate it. So I'm getting 2a square. So here, what is the integration of 1? It is a theta minus 2 cos theta. What is the integration of 2 cos theta? 2 as it is, and integration of cos theta is sin theta. And here limit 0 to pi by 2. And what about this one? Here 0 to pi by 2 cos square theta. I will use reduction formula. So what is it? It is nothing but 2 here, 1 here into pi by 2. So simplify it. So what is the required area? A, 2a square outside. Upper limit is a pi by 2. So theta is pi by 2 minus 2 sin pi by 2. It is a 1 minus lower limit. Theta is a 0. Sin 0 is 0. I will get 0 plus pi by 4. So area equal to 2a square inside pi by 2 minus 2 plus pi by 4. So area equal to 2a square pi by 2 plus pi by 4. It is a 3 pi by 4 minus 2, which is your required answer or required area. So example, find the area inside the circle r equal to a sin theta and outside the cardioid r equal to a in bracket 1 minus cos theta. So it is in polar form. So definitely we know area equal to double integration r dr d theta. And now find the area bounded between these two. R equal to a sin theta. It is this circle where theta equal to 0. Sin 0 is 0. When theta equal to pi by 2, I will get here a. And here r equal to a in bracket 1 minus cos theta is nothing but this is a curve, cardioid in negative direction, because when theta equal to 0, cos 0 is 1, so I am getting 0. When theta is pi by 2, cos pi by 2 is 0, so I will get a. Means here may be the point of intersection. But that point of intersection always you find by equation, not by curve, because here we are tracing roughly curve. So by equation you find points of intersection. So what is that curve? So this is supposed to be a roughly curve. So here theta equal to 0, here theta equal to pi by 2, here theta equal to pi, and this curve is cardioid r equal to a in bracket 1 minus cos theta, and it is a circle r equal to a sin theta. What we want to find inside the circle and outside the cardioid here. So this area we want to find. So what are the limits? Here it shows supposed to be theta equal to 0 to theta equal to pi. But by equation we'll find, see there, r equal to a sin theta and r equal to a in bracket 1 minus cos theta. Find the points of intersection. So equate the values. So a sin theta equal to a in bracket 1 minus cos theta. So a get cancelled. So I am getting sin theta equal to 1 minus cos theta. So here 2 sin theta by 2 cos theta by 2 equal to 2 sin square theta by 2. So 2 get cancelled, 1 sin get cancelled. So I am getting cos theta by 2 equal to sin theta by 2. And therefore tan theta by 2 equal to 1. And therefore theta by 2 equal to tan inverse 1, which is nothing but pi by 4. So what is the theta? So multiply throughout 2. So I am getting theta equal to pi by 2. So definitely that value is theta equal to pi by 2. So what are the limits here finally? Note that here if we take this radial strip, it starts with the inner curve. What is that inner curve? It is a cardioid and outer curve is circle. So I am getting limits are r equal to a in bracket 1 minus cos theta to r equal to a sin theta. And what about the limits of theta? Theta equal to 0 to theta equal to pi by 2. So therefore area A equal to integration 0 to pi by 2 inner integration a in bracket 1 minus cos theta to a sin theta r dr d theta. So definitely first integration with respect to r. So only r inside. So I am getting area equal to integration 0 to pi by 2 inner integration a in bracket 1 minus cos theta to a sin theta. Here r dr and outside d theta. So I am getting area equal to integration 0 to pi by 2. It is a r square by 2, lower limit, upper limit. So lower limit is a in bracket 1 minus cos theta, upper limit is a sin theta, d theta outside. So 1 by 2 is outside. So I am getting area equal to 1 by 2 integration 0 to pi by 2, upper limit square means a square sin square theta minus lower limit a square 1 minus cos theta whole square outside d theta. A square common, you take it is a constant, so outside. So I am getting area equal to a square by 2 integration 0 to pi by 2 sine square theta and square of it. It is a 1 minus 2 cos theta plus cos square theta and outside minus sign. So minus 1 plus 2 cos theta plus cos square theta, but outside minus, so minus cos square theta d theta. Note that for sine square theta and cos square theta, here limits are 0 to pi by 2, and therefore directly we can use reduction formula and remaining the integration. So a square by 2, you should know what is the reduction formula. So for sine square theta, I will write here 2, here 1, means 1 by 2 into pi by 2 minus. So plus, for minus 1, I will get here minus theta plus 2. Integration of this is nothing but 2 sine theta, lower limit 0, upper limit pi by 2 minus here again the reduction formula. I will get 1 by 2 into pi by 2, bracket close. Simplify it, which is your final answer. But note that this bracket same, so cancel plus minus. So area A equal to a square by 2, upper limit it is a pi by 2, so minus pi by 2, sine pi by 2 is a 1, so plus 2 minus 0 I will get. So what is the area? A equal to a square by 2 inside 2 minus pi by 2, which is your required area.